Alright, so this is the formula that we just derived. And let's take a bit of a deeper look into this formula. Yeah. For example, when x is 0, what is p? Well, it's e to the power of 0 if x is 0. It's 1. 1 plus 1 is 2. 1 out of 2 means 1/2. Yeah. If x is very small, then this term here will be very big. So if x is negative, this term will be very big. Yeah, and it will draw this thing to 0. Yeah. Now if x is positive, let's see what happens when x is positive. So you have this formula here, 1 plus, and then we have e to the minus w transpose x. Yeah. So in this case, this stays negative. Yeah. This is positive, because I brought it to the denominator. Now if this is going really big, this will become 0, and 1 divided by 1 is 1. Okay? So the function that we actually draw is gonna be like this. So we have 0, and then we move through half, and we come like this. This function is called sigmoid function, or also called logistic function. Yeah. Let us now take a little bit of a look between naive Bayes and logistics regression. Yeah. There's two different algorithms. In naive Bayes, yeah, what we try to do is, this is what we're looking for. Remember? Y given x, yeah, that this is proportional to x given y times probability of y, right? And let's call this one, these two. These we both estimate. We estimate 1 and 2 to calculate this one here. Yeah? So this, remember, is called a prior, and this here is the likelihood. Yeah? And it's basically the conditional likelihood, because it's upon a label that is given. Yeah? So this is what we do in naive Bayes. Now here, logistics regression, we do something totally different. Here we're actually going to calculate. So here the probability of y given x, in this case, is 1 divided by 1 plus e to the minus w transpose x. Yeah. Now what we're gonna do here is we're gonna do the maximum likelihood estimate on this formula.